Hello students, today we are going to do a quick review of whatever concepts we have discussed so far from 3.1 to 3.5. We discussed about adding decimals, subtracting decimals, multiplying and dividing decimals. More importantly, we discussed how to estimate these and compare the operations, the result of the operations with our estimations. Alright, we'll start with a simple addition of decimal problem. So let's say we have something like 16.34 plus 8.9. Okay. Now clearly we are adding decimals here. So how to add decimals? Let's remember how I am stacking the decimals one below another. The place values have to match. So I will write it exactly like this. The tens place comes under the tens place, right? Now you have the hundreds place here. Here we don't have the hundreds place. So if you don't have a hundreds place, what do? You just put 0 there. Now draw a line. What are we doing? Are we adding or subtracting? We are adding. Okay. Now we know 4 plus 0 is 4. 3 plus 9 is 12. There's a carryover. Now 1 plus 6 plus 8. That's 15. We carry over here. So 1 plus 1 is 2. So don't forget to put the decimal. We have a decimal here. I'm just copying it down here. Right? This is simple addition of the decimals. So if you have something like 16.34 plus 8.90, I can add them up and say my answer is 25.24. But very important thing to understand here is how to check our actual answer with our estimations. Okay, you got this answer, well and good. You know how to add the decimals, well and good. Now, after we get this answer, I would like to check, did I do it correct? What is my estimation and what is the actual answer? Okay, let's see. 16.34. Okay, the estimation could be 16. Why did I say 16? Because I'm rounding 16.34 to its nearest whole number. I'm rounding it. I'm estimating it. So how do you round it? How do you estimate it? Look at the digit in the tens place. Remember, the digit in the tens place is the digit which comes right after the decimal. So if you look at the digit in the tens place, which is 3, which is less than 5. I know 3 is less than 5. So what do? I just cross it off. So the nearest whole number to this decimal is 16. We discussed this in the class, right? Okay, let's take this one. You have 8.90. Okay, I want to see what is the nearest estimate, nearest whole number for this decimal. Again, let's look at the digit in the tens place. You have 9. 9 is greater than or equal to 5. You have 9 in the tens place, which is a digit which is greater than or equal to 5. So what do? You round this to the next whole number. 8.90. 8 is the whole number that you are seeing here. What happens when you round it to the next whole number? What is the next whole number that comes after 8? 9. So my estimate here is 9. So I estimate that 8.90 is almost 9. Okay, that's my nearest estimate. So now let's see. My estimate for this is 16. My estimate for this is 9. Okay. So I know 16 plus 9 is 25. So I estimate that the sum of these two decimals is 25. But what is the actual answer I got? 25.24. Fair enough. That's close. I estimated that the answer is 25. My actual answer is 25.24, which are one and the same almost. So it's always important that when you add or subtract decimals, compare your sum or the difference with your estimate. That way you're not committing mistakes. Okay. Now you don't have to do this all the time, estimating and comparing. Okay. This is only for your reassurance that you are doing it right. Okay. Sometimes in the question, if they ask you, tell me how reasonable your estimate is, then you have to do all this. You have to do your estimates, arrive at the final answer of the estimate, compare it with your actual answer. If they don't ask you, is your estimate reasonable, you don't have to do this. Still, it is a good idea to have some estimates just so you're reassured that your answer is the same as your estimate. That means you did not commit any mistake. Okay, this is how we are comparing our actual answers with our estimates. Okay, all right, let's do one more, which is a difference problem. Now we have completed a sum problem. Now we do a difference problem. Let's see. Let me clear this out. Alright, I'm doing one more here, which is a difference. Difference means subtraction. Sum means addition. So just a quick note here. When I say sum, it means addition. When I say difference, it means subtraction. You know this already. So let's take a difference problem, which is 13.4 minus 9.78. Okay. Oftentimes they give you a question like this. Subtract 13.4 minus 9.78. Okay. It's up to you to stack it properly and arrive at the answer. Okay. They don't stack these decimals for you. So let's do this. I have stacked it here. I have written 13.4 minus 9.78. Do you think I stacked them correctly? Alright, decimal and decimal are stacked properly. Then I have the tens place and tens place here, which are aligned properly. Then I have the hundreds place here. I don't have anything here. If you don't have anything, let's put 0. Okay. So I'm stacking the hundreds place properly. So all the numbers, all the digits in the decimals are stacked well. Okay. Now let's proceed with our subtraction. So 0 minus 8. We can't do this. We can't subtract 8 from 0. So what do? We borrow from the previous column. From the tens place, I am borrowing it into the hundreds place. So 0 now becomes 10, right? Because I borrowed, 4 becomes what? 3, right? Now this is 10 and this is 3. Now I know 10 minus 8 is 2. Okay. Now I have 3 here. 3 minus 7. Can you subtract 7 from 3? No, we can't subtract. So let's proceed. We borrow from here. When I borrow, it becomes 13 and this becomes 2. So I know 13 minus 7 is 6. From 13, if I subtract 7, I'm getting 6. Alright, let's put the decimal as is. Now I have 2 here, I have 9 here. Can I subtract 9 from 2? I can't do that. So let's do the same thing again. Borrow. This becomes 12 and this becomes 0. Because I borrowed, I'm removing 1. So this becomes 0. This becomes 12. 12 minus 9 I know is 3. Right? And now here I have 0. And here also I have 0. 0 minus 0 is 0. I don't have to worry about this part. So now I know the answer is 3.62. Okay. Now 3.62 is the difference of 13.4 and 9.78. So when I give you a question like this, you can just give me an answer like this. Okay, you don't have to do the estimation, but to reassure that you're doing the right thing, let's do the estimation as well. So 13.4, if I round it to the nearest whole number, how do you do that? Look at the tens place. You have 4. I know 4 is less than 5, so I'm just crossing it off. I'm left with 13. 13.4, the nearest whole number is 13. Minus, now let's round this decimal to its nearest whole number, nearest integer. So 9.78, look at the digit in the tens place. You have 7. I know 7 is greater than or equal to 5. So I'm taking this number to its next whole number. What comes after 9? 10. So now my estimate is 3. So I have 3 here. I have 3.62. That's fine. That's a good estimate. I know 3.62 rounds to 4, but that's fine. My estimate is not bad. Okay, so this is how I know I'm doing a fair job of doing the sum or difference. Alright, I repeat again, in the test, if you are just asked to add or subtract, just add or subtract and give the final answer for me. You don't have to do the estimate. But if I ask you, what is a good estimate? About how much? Look at the terms like about, estimate and all those things. If I ask you like that, then you have to estimate. Okay, we'll proceed through more examples so that you get a clear idea. Now, suppose I say so I have $3.73 and my mom gave me $2.50. Okay, so I have this much amount and my mom is giving me this much amount. What is the total that I am having? What is a good estimate? If I ask you, what is a good estimate of the total amount you are having at this point of time? Now, you don't have to do this. You don't have to add it exactly. Because I asked you for estimate. If I ask you what is the estimate of the total amount that you are having now, you would be estimating. Or if I ask you a question like, about how much amount are you having now? If I use words like about or estimate, you know that you have to be estimating and not doing the actual calculations, right? So let's just estimate. This decimal, when I estimate it, okay, or when I round it to the nearest whole number, Look at the digit in the tens place. You have 7. 7 is greater than or equal to 5. Then I know I have to proceed with the next whole number, which is 4. Now look at this. You have 5 in the tens place. If you have a number which is greater than or equal to 5, then you round it to the next whole number. After 2 comes 3. So this number you are rounding it to 4. This number you are rounding it to 3. The total would be 7. So you can say my rough estimate, the total amount that I am having is about, this is an estimation, this is not the exact answer, it is about $7, something like that. Okay, so now I hope you know how to answer the questions when we ask you about estimate or when we ask you the actual answers. When you hear the word estimate or about how much, then you have to estimate. You don't have to do the actual procedure. Okay, now let's proceed with the multiplication. So let's proceed with a simple multiplication of decimals. Okay, so 3.9 times 7.2. So in the test you will be given a dot like this, a big dot. It is not a decimal, it's multiplication. Okay, so you are multiplying 3.9 and 7.2, right? So let's do that. If you are multiplying decimals, when writing it down, don't write the decimals, just write down the numbers. 3.9, I'm ignoring the decimals, I'm just writing it as a number. 39 times 72. Look how I am stacking the digits properly. Yeah, so let me write it here so that we have good space. 39 times 72. Okay, now I'll start with this digit. 2 times 9 is 18. There's a carryover of 1. 2 times 3 is 6 plus 1 is 7, right? Now I'm done with this digit. Let's erase the carryover. Now I want to proceed with this digit. 7 times 9 is 63. There is a carryover of 6. 7 times 3 is 21 plus 6 is 27. Right. Now this is the answer I got, but is this the final answer? No. We should put the decimals. How to put the decimals? Look at this one here. After the decimal you have one digit. Look at this one. After the decimal you have one digit. Total you have 2 digits to take care of. I repeat, in this one after the decimal you have one digit. In this one after the decimal you have one digit. Total 1 plus 1 makes 2. You have to take care of 2 digits, which means start from the right and go back 2 digits. 1, 2. I put a dot there. That's my final answer. Okay, let's do one more. Okay, if you are asked to multiply these two, so I would say I don't write 7.35, I write 735, ignore the decimal, times 3. Where should I write 3? Here, here or here? Let's write it here. Okay, 5 times 3 is 15, 3 times 3 is 9 plus 1 is 10, 3 times 7 is 21 plus 1 is 22. Okay, so now look at this one. After the decimal I have 2 digits. Here I don't have a decimal, so let's not worry about it. So I have 2 digits after the decimal. I have to take care of 2 digits. So from the right, let's go back 2 digits. Put a dot here. Okay, so the answer would be 22.05. Okay, let's do one more. Okay, so 3.57, I'm writing it as 357. I'm ignoring the decimals. Times 3.2, I'm writing it as 32. Where should I write? Align them properly. Okay, now let's start with these digits. 2 times 7 is 14. There is a carryover of 1. 2 times 5 is 10. There is a carryover of 1. So 10 plus 1 is 11. 2 times 3 is 6 plus 1 is 7. I'm done with this. Let's erase these carryovers. 3 times 7 is 21. Where should I write 21? Write it here. There's a carryover of 2. You can put 0 here because there is nothing. Now 3 times 5 is 15 plus 2 is 17. There's a carryover of 1. 3 times 3 is 9 plus 1 is 10. Now let's add them up. 4, 2, 7 plus 7 is 14. Now this is my answer, but is this the final answer? No, we have to take care of the decimals. Look at this one. After the decimal, you have 2 digits to take care of. After the decimal, you have 1 digit to take care of. You have 2 here, you have 1 here. Total, you have 3. You have to take care of 3 digits. So start from the right, go back 3 digits. 1, 2, 3. Put a dot there. And that's your final answer. That's it. Okay, did I do this right? Let's estimate. You don't have to show this in the test, but you can just estimate 3.5. If you estimate it, it's roughly 4. 3.21, if you estimate it, it's roughly 3. So 4 times 3 will give me 12. I got 11.4 here. Not bad. That's close. So fair enough. I did my multiplication okay. Okay. So this is how you do. But this is multiplication. You might be asked to multiply 2 decimals, but sometimes you might be given word problems. Okay, because situations in life are not always simple. You have to apply our math to real life situations. Okay, it could be something like, see, I got 5 pence. I would say Martha got 5 pence. Okay, for $1.35 each. Oh my god, these are costly pens. I don't think we have. Okay, so 5 pence each is 1.35. Now I would ask you, so Martha bought 5 pens, $1.35 each. What is a good estimate for the total amount Martha spent? Okay, so 5 pence, 1.35. We know she got 5 pence, $1.35 each. The total amount that she spent would be 5 times 1.35, right? So 5 times 1.35. So let's estimate. We are not doing the actual multiplication here. Just remember that we are estimating. If I ask you what is a good estimate, or if I ask you about about how much Martha spent. Okay, then you estimate, you don't do the actual multiplication. So let's estimate 5 is 5 only, you don't have to round it. Now 1.35, you have to round it to the nearest whole number, to the nearest integer. So let's look at 3. 3 is less than 5. Cross it off, that's 1. My estimate is 5, right? So I would say it would be $5. Okay, so if I said, she spent 1.95, just take an example, just imagine each pen is 1.95, then what is a good estimate? Okay, 5 times 1.95, that's nothing but 5 times, look at the tens place, you have 9 here, which is greater than 5, so round it to the nearest whole number. What comes after 1? Because you have a number in the digits place which is greater than 5, round it to the next whole number, which is 2. My estimate is 10. Okay, so that's just a small example. Alright, let's do the division here. Again, some questions may be directly asked, like, divide this decimal by this decimal, but sometimes you might be given a word problem. Okay, so let's take 5.35 divided by 0.5. Okay, so it's 5. We are not estimating, we are doing the actual division, because the question will be like this: divide this by this. Okay, then what I do is, I know I have to divide 5.35 by 0.5, but the trick here is to make the denominator as a whole number. Okay, not estimate, we are converting it into a whole number. So how do you convert 0.5 to a whole number? Let's multiply both sides by 10. Let's see what happens. Okay, so 5.35, if I multiply by 10, the decimal moves to the next place. It would be 53.5, right? Divided by, when I'm multiplying this by 10, the decimal moves to the next place. It would be 5. So now I have a denominator which is nice and round. This is 5. Let's multiply 53.5 divided by 5. Let's divide that. I'm sorry. Okay, this is plain old division that we know. 5 ones 5. 3. I have a decimal here, so I put a decimal, right? So I have 35. 5 times 7 is, I know, 35. That's a remainder of 0. So I know 1.7 is the quotient, so 1.7 is the answer. 5 times 1.7 gives me 53.5. So 1.7.